Good morning, everyone. In today's class, we are going to start with new topic that is push down automata. In this unit, we are going to study about what is push down automata, what is deterministic and non-deterministic push down automata, and its conversion into context-free grammar and its vice versa, and Pitternet model. So starting with push down automata, I will start it with physical model of push down automata. What is the difference between finite state machine and push down automata? सबसे पहले मैं ये बात करूंगा कि कहाँ finite state machine फेल हो रही थी और क्या एडिशन किए गए उसमें जिससे हमको पुश डाउन ऑटोमेटा उसका सुपर सेट मशीन मिला है. तो सबसे पहली बात कि आई विल डिस्कस अबाउट द physical model of finite state machine, which I have discussed in earlier classes also. In this physical model of finite state machine, if you can see, there is a input tape on the top of this machine, which is in which input string is written from left to right, and this dollar symbol symbolizes the end marker. That means here the string is getting to its end. Okay, and a read only head is used to read the string. This is read only head, which is used to read the string from left to right. It moves from left to right and it reads one symbol at a time. And this read-only head is connected to this finite control mechanism. This finite control mechanism actually consists of some states and a pointer which tells us that what transition is being done right now and what is the current state of on which the control of machine is present. And this finite control mechanisms also possesses the transition table where rules are written that on reading small a, where we will move from capital A, or from reading from state B, on reading small a, where we will move. So these all transition rules are written here in transition tables. By reading these rules, this pointer will make its move one by one, and as the string will get to this dollar, as this read only head reaches to this dollar, that means our string has came to its end. Then we'll check on which state we are presently standing. If it is a final state, we will say that our string is valid. That means we'll say yes, our string is valid. And if at the end, if we are on some non-final state, we'll say that no, string is not valid. Okay. In this way, we were working in finite state machine. Now the problem which we faced in finite state machine, that we encountered a language which was something like this. Just a second. It was L is equals to 0 to the power n, 1 to the power n, where n is greater than or equals to 1. Now, in this language, what is happening, that number of zeros and number of ones are equal. That means जितने भी zeros आएंगे followed by उतने ही number of ones आएंगे. Now यहाँ problem क्यों हो रही थी and why finite state machine for this language set was not possible? Because यहाँ पर हमें याद रखने की requirement थी. मतलब we need to memorize ki what strings we have read in past. That means if I have, suppose I have read 3 zeros in past, then I need to memorize that I have read 3 zeros. That means ab in future I have to read 3 ones only. Okay. So due to the absence of memory element in finite state machine, such languages cannot be recognized. So what we have done, we have incorporated a memory element into this finite state machine, and we called it as stack. Okay. So stack is the data structure we use for incorporating memory element in our finite state machine. And what we got is PDA. So these are the components. These component does not exist physically, but if we imagine it, that what all components are working to form a PDA, then these are the components which work along way to form a PDA or push down automata. So the only addition here is this stack. In absence of this stack, or in absence of this memory element, this machine was only a finite control mechanism, was only a finite state machine, which was not able to recognize those languages, which one of which I illustrated just now. Now, if I say it in general language, then I can write it like this. Just a second. I can write in simple language, I can write that PDA is equals to finite state machine plus a memory element. And what is that memory element? That memory element is stack. Okay. So ये तो बात हुई जनरल लैंग्वेज में समझने की कि व्हाट इज पीडीए. And PDA is actually, you can say that where finite state machine fails to recognize the languages due to the lack of memory element, there the push down automata came into existence. And there was not no big difference between finite state machine and push down automata. Just a stack was added to memorize the past string, so that future string can be taken accordingly. Now, as I have also told you earlier, that for every set acceptor, there is a set generator. So for this set acceptor PDA, there is a set generator which we have studied in last few classes of last unit, that is context-free grammar. So for every PDA, there is a context-free grammar, and for every context-free grammar, there is a PDA. Now, talking about the formal definition of PDA, a PDA, a push-down automata, is defined with the help of 7 tuples. And what are those 7 tuples? Q, sigma, tau, tel, Q naught, Z naught, F. Now, few of these tuples are known to you, like Q, sigma, del, Q naught, and F. And few are introduced new here, like this one, tau. We call this symbol as tau, T-O-U, okay? And this is Z0, Z naught. These are the new symbols which are being introduced here in PDA, which was not there present in finite state machine. So what are these tuples? Let us take a look one by one. First of all, I will talk about Q. Q is the finite set of states. So every machine has some states, we studied in finite state machine. यहाँ पर भी कुछ states हैं. So we'll symbolize it with capital Q. Sigma is the set of input alphabet. Whatever input alphabet we are using in our machine will be symbolized by sigma, set sigma. Tau is the set of stack symbol. Whatever stack symbol you are going to use to perform push and pop operation in the stack are recognized by this tau. Now, it is up to your discretion that what symbols you want to use, whether you want to use some different symbols or whether you want to use the symbols similar to input alphabet. It is totally up to you. It will not make any difference in our push down automata. Okay. Now, next is transition function. This transition function, as I told you earlier also, this is a function which tells us the pattern of movement in a machine. So what actually transition function, how it is defined, I'll tell you after a few minutes. But for now, you remember that transition function is a function that tells us the pattern of movement in a machine, that how we are going to move from one state to another is being described by this del. Q naught की बात करें, Q0 is the initial state. That means whenever machine is being initialized or started, what state we will our machine's control will be in. So Q0 is that initial state, and it is the one of the state from Q. So Q से एक state को हम designate करते हैं initial state, ठीक है? Similarly, Z naught की बात करें तो Z naught is the initial stack symbol. So whenever we initialize the stack in our PDA, it will consist of Z naught by default. And what is its role? I'll discuss it later on. And lastly, F, that is set of final states. So as in finite state machine, you learned about F, that is final state. The same role is here also, that whenever we reach to the final state, that means it is the if we on reading the complete string, if we reach to the final state, that means it is a valid string. So these are the 7 tuples which are used to define a push down automata. So if you want, if you have to describe a PDA, you have to use this definition in your question paper. Now I will talk about the transition function. Transition function of PDA. Transition function of PDA is actually a 3D mapping in which 3 things are seen for making a movement. As in finite state machine, we were only focusing on 2 things, that on which states we are presently at and what input alphabet we are getting. और उसके बेसिस पर हम अपना मूवमेंट करते थे फाइनाइट स्टेट मशीन में. तो वहां पर लेफ्ट हैंड साइड पे क्यू क्रॉस सिग्मा लिखते थे. यहाँ पर क्यू क्रॉस सिग्मा क्रॉस टाउ इसलिए लिख रहे हैं बिकॉज यहाँ 3 चीजें हम देखते हैं किसी भी मूवमेंट को करने के लिए. पहली चीज कि हम किस स्टेट पर खड़े हैं, दूसरी चीज कि हमारा इनपुट अल्फाबेट क्या आ रहा है, और तीसरी चीज कि स्टैक टॉप पे क्या है. इन 3 चीजों को देखकर हम अपना मूवमेंट करते हैं एंड दैट मूवमेंट करने के बाद हम जो राइट हैंड साइड पर मैंने लिखा है वो लिखा है q क्रॉस टाउ एस्ट्रिक्स. नाउ दिस एस्ट्रिक इज द क्लीन क्लोजर which you have studied in regular expression. It means any possible combination of stack symbols, that is tau, including epsilon. So here epsilon can also come. So I have marked here what are all these symbols, that q stands for states, sigma stands for input alphabet, tau stands for stack symbol, or specifically if I say stack top, then again in right hand side in the answer I will write some state, then on which state I am going after reading all these things, and what possible combination of stack symbols including epsilon. That means kya push और क्या pop हो रहा है stack से, ये लिखता हूं मैं. So this is the transition function for PDA. I hope you understood this thing. Now one more thing I would like to share here, that a transition table, we cannot write any transition table as we were doing in finite state machine, that we can make transition diagram and we can make transition table for the finite state machine. Both the things we can write there. But यहाँ पर क्या होता है, हम transition table नहीं लिख सकते. And why so? Because अगर आप यहाँ देखें तो यहाँ 3D mapping हो रही है. What is 3D mapping? 3D mapping is actually यहाँ पर लेफ्ट हैंड साइड पर आपको देखना होता है कि कितनी चीजें आप कितने टपल्स यूज कर रहे हैं. सपोज अगर आपको ट्रांजिशन टेबल बनाना होता है, तो अगर आपको याद हो तो फाइनाइट स्टेट मशीन में कुछ इस तरीके का ट्रांजिशन फंक्शन था, क्यू क्रॉस सिग्मा मैप्स टू क्यू. सो इट मींस कि हमें ट्रांजिशन टेबल में क्या करना है, हमें ट्रांजिशन टेबल पे इधर स्टेट्स लिख देनी होती थी, ओके, और इधर लिख देना होता था इनपुट अल्फाबेट, और यहाँ पर बीच में हम लिखते थे जो भी हमको आउटपुट स्टेट मिल रही होती. बट व्हाट इज हैपनिंग हियर, एक्चुअली यहाँ पर क्यों ट्रांजिशन टेबल पॉसिबल नहीं है, क्योंकि यहाँ पर अगर आप देखें तो लेट्स से एक टेबल आपने बनाई, ओके, आपने एक्स एक्सिस में चलिए लिख दिया क्यू, ओके, वाई एक्सिस में लिख दिया आपने चलिए सिग्मा, and now where you will write this tau, because for that you need z axis, ठीक है, and you cannot write 3D table in a 2D space, okay, that is why its table is not possible. So what so then how we make it make a PDA then? So we use transition rules to write a PDA. So we will write transition rules, and in some literature, in some books, you can also find transition diagram also. So I will also discuss those transition diagrams later on. But for now, you just remember that transition table is not at all possible for PDA because 3D mapping is not possible. Thank you so much. This was all about PDA. In later classes, I will discuss about how to make PDA case by case. I'll discuss all those things. Thank you so much.